I know. Many of you are saying this design stuff. What the heck? When we gonna program? Well, again, if you took some time and actually went through this and you actually focused on this and actually listened to what I said, you'll be programming in no time. And not only will you be programming in no time, you'll be doing so with a lot more confidence, okay? Because you know that your solution is correct. As you see here, we have went from one line of code to a few lines of code to several lines of code in a matter of a couple weeks. This is not going to end, okay? I'm not saying our programs are going to get to 1,000 lines of code, but you're going to be shocked at how many lines of code that it actually will get. And even that is very minimal to what the real world programming is all about, where you actually write thousands of lines of code. But regardless of how many lines of code you actually write, if you just follow these steps and do things one at a time and focus on what you're doing without trying to rush through it, you'll get done much more quickly with much more success. Okay? Anyway, so enough preaching about designing. I'm not going to preach anymore. And that's a lie. Okay? So we have everything done. Now it's time to go program. All right, so let's go over here and program. And I'm not going to bore you with all my programming, but I showed you this before and how this whole thing should actually work. Okay, and let's do it one more time, and then we'll go look at the code. All right, so in this case here, Bob walks in first. Oops, Bob walks in first. I'm sorry about that static. Hopefully, that'll be it. Get a little bit of issue here. Okay, so Bob walks in first. He wants a couple snowboards and a couple snowboards. I'm gonna put that back there. Maybe that will end the static. Okay, and we calculate, and you see 40, 60, 100. Okay, I'm actually using my test cases here, correct? All right, so 40, 60, 100, 100, 2, 2, 100. Beautiful. And then the next person walks in. I'll clear this, and we see we keep our daily summary here. And then, I don't know, Sally walks in with her family, and she wants to, like I said before, she wanted the exact same thing I wanted, 40, 60, 100. And as you see, these totals incremented, okay? So why do they increment and these didn't? Because we used our scope correctly. All right, so there you go. We clear everything out and we can exit the program and go from there. So let's go look and see how this is actually done. Okay, first things first, we're going to declare our variables. The only variables that we will declare, okay, I'm going to bring this up over here, would be, okay, our local variables. So these 1, 2, 3, 4, 5, 6 local variables. 1, 2, 3, 4, 5, 6 local variables. My inputs and my outputs I defined as local. Do you see those? Okay. My class level variables, which I had those two, and I had one more down here for customer counts, get defined, okay, up here. Okay, the day total, the boards, the days, and the customers. Looks like I have 4 of those. Is that right? Let me go back to that. I thought I had 3. Let's see. Whoops. And yeah, 1, 2, 3, 4. I was actually right. See, that's the 4th one, and there's the 3rd one. And so back to my program here. One up. There we go. Yep. 1, 2, 3, 4. Okay. Once again, I know I'm probably confusing you a little bit when you see that word double. Double is a decimal. When you see the word double, that also means decimal. You can use either one. Don't get confused by it. I'll explain a little bit more later on in the course. I probably should have changed it, and I apologize I did not. But if you see the word double, that means decimal. It's the exact same thing, okay? For your programs, you can use either one. If you want to copy mine and use double, that's perfectly fine. If you're comfortable just using integer and decimal, use that. That's perfectly cool, all right? Probably should have changed it. All right, so now I have this. I go get my inputs. See how I did this? The exact same way as the previous programs, okay? And I do my calculations. Well, those calculations, for the most part, came exactly from my code here, right? I'm going to charges for snowboards. There we go. Snowboards with boots. Okay, that was this one. My rental total, there you go. I even put a little comment in there that I'm calculating my customer rental here. Then I'm going to do my daily summary, okay, where I actually accumulate. you'll notice right here I have this thing called plus equals and all this accumulation. This is something that's consistent across pretty many programming languages. I'm not going to say all of them, that would probably be silly. But this is a kind of a shortcut of this right here. So if I said day total, I could spell it, okay, equals DBL day total, okay, plus DBL rental total. This is the exact same thing. These two are the same. So this is how I wrote it, right? And this is how I wrote this actually in my design, right? Right here. Where my this was daily total charges. There they are right there, okay? And so this is how I did that right here. You see how it almost identical to this with this the proper naming conventions, correct? A shortcut in program, and you can write it like this. By all means, feel free to write it like this. You're not going to hear me say anything. If that makes it makes it easier for you to understand, write it like this. However, a shortcut in programming is plus equals. Plus equals says I'm going to take whatever on the left-hand side of the equal sign and add this to it. I'm going to take whatever on the left-hand side of the equal sign. So in this case, it's still a class level variable. It's going to have the contents of the one before, and I'm going to add this to it. Does that make sense? Okay, so just another way of looking at and writing it. If you don't understand that, or you're like, oh God, Bob, there's too many new things, keep it the way you know it, okay? You can say DBL day total equals DBL day total plus DBL rental total. I'm perfectly fine with that. We did everything else here. Let's go back to this up here, and as you can see, I walked through it. I got my my customer count. I added one to it, and I divided. And then I displayed all my totals and with all my currencies being formatted. Make sure you format all your currencies. Don't avoid that. Learn how to do it if you don't know how to do it. And look at that. That's my program. And, you know, all in all, it wasn't too hard. I don't think, if you just take one thing at a time. Yeah, there's some new stuff here. Well, there's going to be new stuff just about every week. Okay, you got a lot more to learn about programming, but that's where we are right now. Okay, we've now gone through the whole checklist. All right, I already showed you what happens when we actually run this thing correctly, right? And once again, let's do it one more time. And again, we'll put Bob in here, give him a number, okay? And we'll put 2 and 2, again, going with our test cases, correct? Here's our test cases right here. Let's go ahead and bring that up here. And so we had snowboards 2, 2, and so our expected results are this right here. And so if I hit calculate, 40, 60, 100, yay. Okay, 2, 2, yep, 100 is my daily total charges, yep, my customer count is 1, and my average is 100. That means that worked, okay? Again, we have another test case to make sure things are accumulating. And so let's go ahead and clear that out, and we'll bring Sally in again. That's not Sally, that's Saki. I don't know what Saki is. Oh God, you get the idea. We'll just leave it at Saki. For some reason, I want to call her Saki. That's her nickname. I have no idea. I'll just stop there. Anyway, we calculate, and I should be getting these results, and these should be accumulated. So we calculate again, 40, 60, 100, 4, 4. My 2, I don't display my customer count, but my average should be 100. There you go. Here's the great news about that. I tested my logic, I wrote my program, I used my test cases against my program, I got the results I expected, I am finished. I can walk out of this knowing I am confident my program works 100%. That's beautiful, that's great. And it all because you thought about it up front, okay? Once again, if you don't think about it up front, you're not thinking about test cases, you don't know if it all works or not. Okay, you don't know because you just haven't thought about it. But if you think about it and you know what the test cases should be, you know you exhausted the test cases to test this particular piece of logic, we know we're done here. I can't stress that enough. We got to make sure our program works. I want to show you one more thing here, and this to show you the difference between class level, scope, and so on. Let's just pretend we took all of these. And I'm going to cut those, and we'll make those into local. Because I put them down there, they now become local variables. Okay, so remember, again, scope is about the lifetime of the variable. You have local, you have class. We have walked through this, correct? The program determines what's local based upon it being declared within the procedure. That's what we did here. They're class level variables if they're declared outside the procedure, like I just had them a second ago. I just moved these down as local. All right, let's look at this and see what happens. So I put Bob here, and I put this here, and I put 2, 2, and I hit calculate. Everything looks good. Again, if I sit back and I look at my, I'm gonna get rid of that. If I look at my, goodness, my design, unless I got rid of everything, so I'm not gonna go find it, but I basically wanted 40, 40, 2, 2, 100, 100, right? Everything's beautiful, and 40, 40, 100. And then we cleared, and then we wanted Sally in here. Okay, and once again, 2, 2. All this should be 40, 60, 100. This should go to 200. This should be to 4, 4, and this should stay at 100. Hit calculate, and look what happened. The 100, these did not accumulate. They did not accumulate. Why? I'm going to go look at this. We put these things down in local variables. We put these things down and declared them within our button. So what happened is all the code remained the same. I accumulated them, but every time we hit end sub, it cleared them from memory and it cleared its contents. So every time we go here, it starts at 0 because it redeclares it again here. Does that make sense? Okay. So if you need to hold the contents, they must be class level variables. And to define a class level variable in a program, you must declare the variables outside of the procedures, like this right here. You see how they're not in any procedures at all? And there you go. Okay, now, sometimes I see students do this. They'll sit back and take all of these, instead of making them local, they'll put these up here. Okay, let's see how this works. So they made them all class level variables. And we'll sit back and we actually put this back in here again, and we'll put that there, 2, 2, and hit calculate, and everything looks good. I clear. I put Sally here, 2, 2. Whoops, Sally messed up. So, okay, her ID is 2. We'll put 2, 2 again. You know what the thing should be, 46. Oh, this accumulated. Huh. Everything seemed to work. Wow, okay, well that looks pretty good. So why don't I just make them all class level variables? And the answer to your question here is you can, and they will work. But here's the problem, okay? So if I sat back and I ran this, let's just say we're gonna rent these snowboards, you know, early fall. Not, you know, maybe we're out in Colorado, there's a little bit of snow in the mountains, not too much, so not many people are coming in. Bob comes in and he rents this, or Bib comes in. I'm tired of fixing my typing. I think you're probably tired of watching me do it. And he does this, okay? And we have our summary here, and they clear it for the next customer. The next customer doesn't come in for 6 hours because it's a really late day on the mountains. Nobody's skiing today, okay? And so it sits there, and it sits there, and it sits there. So those variables, okay, that we declared as class level variables are still sitting in memory, all right? Is that a big deal? Well, maybe not, based upon how much memory you have on your computer. But if every program did that and was taking up memory for no reason whatsoever, it does become a problem. It slows the computer down. So we as professional programmers not only want to write a good program, not only want to make sure that our program works correctly, we also want to maximize our resources, our computer's resources, to make sure our computer is always working at top-notch speed. And in doing so, once we're done with a variable, we should get rid of the variable. And so that, again, that's all based upon local scope. So declaring these as class level variables, yes, it will work. There is no doubt about it. And I'm going to guess a few of you are going to hand in some programs that is going to do this. And you're going to hear me say, why'd you make everything class level variables for? And if you did that, refer back to this video once again. Though it works, it's not the answer. The answer is maximize your resources. So for those things you do not need to keep around after the process is finished, make sure they are local variables. Does that make sense? I hope so. My final thing we're going to talk about, we talked about it a little bit, is this thing called constants. Once again, a constant is a variable. It's a memory location that's going to hold a value. You cannot change a constant in your code. Once you have it, it's there. People use constants for means of holding a value. I know I have single here. I'm really confusing you. Single is a decimal also, okay? I'll show you that a little bit later on. Never use single right now. Just use either decimal or double. My suggestion is just use decimal until later on you get comfortable with this, and I'll explain what double means and single means and so on, okay? So in this case, I made these constants. I put them up here. All constants should be class level constants. Why? Because if we're going to have a constant in our program, we want people to be able to find them very easily. And so the goal of the constant is it's sitting up here, and we define it up here, and it could be used anywhere in our program. In this procedure, and you're going to find out later on, you're going to have a lot of other procedures, and they could be used in other procedures too. So we want to make them class level, number one, okay? Number two, the whole idea is a place that we can easily find it, so if they increase the price or decrease the price, we can go in and change this very quickly. If we refer to this constant multiple places within our program, we define it one time, and all we do is just reference the actual constant, like DBL board rate, in multiple places, and that's how that works. Don't make constants hard. In some cases, I'm not too concerned if you use constants or not. Okay, some teachers might be, some instructors might be. I'm not one of those, but for the most part, that's what a constant is. It's a variable that holds a value, so you can refer to it multiple times. All right. A big reason, like like I said, it's hard for you to vision this, but later on, you're going to have multiple events and multiple procedures throughout your program. You might reference that price over and over again. So if you hard coded it all through your program, and all of a sudden the owner came in and said, you know what, I'm going to start charging $25 for just the board. You would have to go find it all through your program. If you have it like this as a constant and you already set it, all you do is change it right here, and that change in a way cascades down, meaning you're going to refer to it here, and it's always going to be the right price. Does that make sense? You might want to listen to that one more time, but that's the whole idea of a constant. Okay, pretty busy couple weeks, I know. Hopefully this makes sense to you, okay? Try your hand at this. Ask your instructors good questions. Make sure you understand, but also make sure you're following exactly what's being instructed to you. Try not to, if you get confused, and you go off on the internet and find other alternatives, I'd rather you not do that. Stay focused on what we're giving you. Use our examples that's there for you in Blackboard. Download them, print them off, or whatever, and try to understand them and apply your solutions to them. There's a reason why we're doing this, and you'll discover that as you continue on with the course and courses throughout the curriculum. All right, I wish you good luck.